Hello, my name is Dr. Winslow. I am a mentor for the Army Ants 3792, and I am the programming mentor for the team. And I've been helping out the robot in 3 days as far as the programming architecture for the project. We are programming in LabVIEW, and we've set up most of the core routines, the begin, the teleop with state machines, so that we're able to very quickly go through and initialize and begin all of the individual I/O, the joysticks, the motor controllers, the solenoids, etc. And then in teleop, we have a second state machine in there that we read all of our inputs in individual states, we perform all of our calculations in individual states, and then we perform all of the writing to the outputs in individual states as well. So it's more of a sequential state machine that just zips straight on through, and it provides very quick development. We're able to create sub-VIs in each individual state, that those sub-VIs can be handed off to individual developers on our team. And after those developers develop that subroutine, that sub-VI, it can be plugged back into the architecture, and we very quickly can work in parallel to achieve our code in a short period of time.
This year, I'm evaluating the Limelight V1. It's a dedicated vision control module with a web interface and camera and LEDs built into it. Through a web interface, we're able to set up predefined profiles to search for certain objects. It runs a lot faster than anything that we got on the Robo Rio at about 90 frames per second. Connected to the Limelight is our Robo Rio control bench. We have a Robo Rio, a router or voltage regulation module, power distribution board, pneumatics control module, Talon SRX, and a camera. This allows us to debug code, connectivity issues through the network, CAN, any power draw issues that we might face without necessarily requiring a robot and its control to be built already. We can image everything and get everything ready for the new season.
Okay, so as I had mentioned, we've set up state machines in each of the begin and teleop sub-VIs. And this on screen here is our begin VI. We have the state machine has the while loop. It has a type-def enum, which has all of the list of states predefined into the enum. That is driving a shift register, which drives the case selector of a case statement. Here's the case statement. And as you can see, as this begin executes, we start from the network setup. And in the network setup case, we initialize our network tables. Then it proceeds on to the joystick setup, where we initialize our joysticks, left and right joysticks. We initialize our drivetrain setup, including the encoders for the left and right side of our robot, as well as the drive motors themselves. Proceeding on to the ball intake, we have a motor to intake the large orange balls. I guess those are cargo. And then proceeding on to our robot, will have a wrist, which will have some solenoids on it to actuate a wrist up and down. Then to the hatch deployment, which has more solenoids to deploy the hatch onto the various modules. The compressor for running all of our pneumatics. Our lift, we have a lift arm that will have motors on it with Talon SRX motor controllers. So here we can see the initialization of the Talon SRX motor controllers. We have a gyro to measure the azimuthal angle of the robot as it drives around. We have a potentiometer on the arm of our robot to measure the angle of the arm. And that's everything that we are initializing inside of Begin. So I just shown you the state machine inside of Begin. Here is the state machine that we have inside of our teleop. Once again, it is a while loop being driven by a type-def enum on a shift register. That shift register is driving the case selector of the case statement inside. Here is the case statement. The elements of the enum define the states of the state machine. We have this as a sequential state machine, so every iteration it just adds one to the enum, so it proceeds on to the next state. In the states for our teleop, we start from reading our network tables, which could potentially transfer data from the dashboard back to the RoboRio, reading the actual value of the left and right joysticks, reading our gyro. By the way, all of these individual cases are modifying a type def cluster that is held on this second shift register. Here is a view of what our type def cluster contains on the front panel. So all of these items are contained inside of the cluster, the joystick axes, the joystick buttons, all of our motor values that we will be outputting, the status of our solenoids, everything is contained inside one singular cluster. And that cluster is contained on this shift register on the block diagram that just gets passed from state to state to state. And inside each state, for example, as we read our gyro, if I open up this sub-VI4 reading the gyro, we see how we have our type def cluster for our local data coming in. We get the ref num for our gyro, we read the gyro angle, and we push that gyro angle into the cluster and send the cluster out. And that is performed in each of the individual states. We unbundle the values that we need, perform operations, and then rebundle the new values into the cluster. And as this state machine executes through, it's a sequential state machine, so it goes through this list of states in order from top to bottom, doing one execution each, and reading our drive encoders, calculating the wrist, calculating the drive, calculating our flywheels, etc. As we go on through all of our calculations, then we get to all of our writes, where we are actually sending values out to our motor controllers, to our solenoids and such. To our drive motors, for example. Here's our drive motors. So we have the twist of our joystick and the forward axis of our joystick that are writing a standard arcade drive style for the drive of our robot, the chassis. What else do we have in here? We have the ending state, by the way. When this reaches the ending state, the end teleop, down here we have logic that whenever that state coming in is equal to end teleop, that terminates the while loop. So that would be one complete execution of teleop. And as you know, in robot main, the teleop sub-VI will be called repetitively during the teleop phase of the game. And that's the design of our state machine for teleop. Thanks for watching. Like and subscribe. Bam.